So we have our parts labeled here. ABC being sides, we have letters ABC for angles, vertices, and we have H for height. Normally you'd approach this and you'd say, oh, area for that triangle is 1/2 base times height. And that's probably the way you've seen it before. Base and height, typical typically perpendicular. B is just happens to be on the bottom here, but that is the base for convenience. Now, what happens if we don't know the height? We need a way to still figure out the area. This is the area of a triangle that does not have a right angle, whether it be the sides being a right angle or even a height that we know. What if all we know are sides and angles? And we know they're not 90 degrees. We know it's not a Pythagorean triple. So what the question really becomes, if we don't know H, we want H because 1/2 base times height is really nice. How can I get H? So if that was the unknown, what equation, what setup could I write with H in it? I'll give you a really big hint. Today we're talking about law of sine. You sine, good. You caught that hint. That's good. Sine of what? Give me, sine of what? What do you want to do? Sine of B? Let's see. Let's go sine of C. If I said sine of C, we need to go back to saying, oh, well, that's in a right triangle. Well, we got a right triangle there. Isn't that right-hand side a right triangle? Okay. So sine of C equals what fraction? H over A. Okay. Which could be A times sine of C equals H. So we can manipulate that, find H, and suddenly it's 1/2 B times A sine C. Okay? Good. Let's say we don't like C. Let's say we like A. Let's start over. Do I have a right triangle on the left-hand side? Cut it in half. Cut it. Okay. So if I had that, sine of A would be the ratio I'd use. What's the fraction? H over C, which becomes C times sine A equals H, which is another way we can get H. Why am I using angle A? Because it's in that right triangle when I cut it down. I also did C on the right-hand side. Can't use B. Because B is not in a right triangle, and B does not have H as one of the sides in the triangle. But conveniently, because H, the height is perpendicular to the base here, the side, we have these angles that do work. Our main purpose here is we've been taught since we were probably, I don't know, when you probably saw first time area of a triangle, 5th, 4th grade, okay? 1/2 base times height. And in fact, your math teacher's been reminding you since then, it's not just base times height, it's 1/2 base times height. But we come across this problem of what if we don't know the height? Now that we've had trig, we can manipulate it to come up with another way to represent it. Do you agree if I had just this problem right here with A, C, and H, this is the way you'd solve for H? Yes. Yeah. So what that is the area now becomes, in that case, 1/2 B times C sine A. So our new equations we could use are here and here. So that's how we get to it. We're not going to have to do this develop each time. I just want you to see, we still use area of a triangle, 1/2 base times height, but we're kind of manipulating it to get the extra information. We're very limited if we don't know the height. But with trig, we can find it. So that's our rule. Let's kind of get the last piece, because we only got 2, but really we have 3 angles there. So let's see. One of them is 1/2 AB sine C. One of them is 1/2 BC sine A. What's the third one? A or B or B or A? Doesn't matter. It's multiplication of points or lengths. Okay, so the third one's probably going to have a 1/2. Something, something, sine, what? What's the letter that's not in sine yet? B. All right. All right, now let's see. Here I had C, and then the lowercase letters, the sides were A and B. Here it was A, and the lowercase letters were B and C. What do you think it is here? Ah, it's the other sides. A, C, it's the other letters. So it's 1/2 AC sine B. Okay, those are your three equations for area of a non-right triangle. You need two sides and the angle. But wait, we could look further. Pick one of them. Which one? First, second, or third? Second one. Okay, that one right there. Let's just kind of highlight the parts that we're using. We have A, we have B, we have C. Kind of looks almost like a side angle side idea. If you know two sides and the angle between. Do the other ones fit that? If you pick the angle, is it the two sides next to it? Here I have C. Here's C. A and B are the ones next to it. We go B. A and C are the ones next to it. So if we have a side angle side type setup, we can actually use this to find the area of a triangle. That's our goal. That's our first start. It's not specifically law of sines. It's kind of an offshoot of that. We'll get to law of sines in a minute. So there's your area of a triangle rule. Any triangle ABC with side lengths A, B, and C has that area. 1/2 BC sine A, 1/2 AC sine B, and then 1/2 AB sine C. Same thing I just wrote. Maybe the order is switched, but it's the same idea, same parts. We'll use this when we have an area of a triangle with no right angle, whether it be a right triangle or whether it be a height. So we look at the two to the right. Does that fit what we need? Okay, so I'm not even worried here on the first one. Whether it's A, B, or C for the angle, I'm just going to trust the setup. It's 1/2, two sides multiplied together, then sine of the angle between them. This is side angle side is what we're working with here when we have this area of a triangle. So for number one, it's going to be area is 1/2 6 times 8 times sine of 51. Hopefully you haven't forgot how to work a calculator. Sometimes we can do things without the calculator, like, oh, hey, it's 24 sine 51.
No way. Oh, God. Too much.
All right, what do we got? About 18.7. We'll go 18.7 centimeters squared. Okay? We didn't have to find the height. We didn't sit there and draw in a height and then use sine to get to the height and then plug it back in. This part right here, this 8 sine 51, is actually what the height is. So if you did that alone, that would give you the height. But we don't care about those small steps. It's here's your beginning step, get to the area, last step. Okay, do the next one. So we get about 9.1 inches squared. Okay? If you haven't tried it yet, make sure you're trying to plug in your calculator so you don't forget how to use your calculator. To this. Okay, we're going to kind of lead us to law of sine. So let's kind of shrink this stuff down here.
Wait, that wasn't law of sine.
That was not. That's area of a triangle. Okay, let's look here. I'm going to use this to lead to the next law of sines. Why it's useful is, well, there's sine in all of these. That helps. And I have equivalence. So I have some equal. What do all of those statements have in common?
They all use sine.
They all have signs.
Okay, now, they all have sine, but it's not that there's a value to sine, because sine of C is different than sine of A is different than sine of B. But in terms of a common factor, what do they have? They have a 1/2, right? And they have letters. Now, do they all have the same letters?
No. Yes. A, B, and C.
Okay, but capital C and lowercase c are different things.
They do all have the same letters. S-I-N.
Thank you. Okay, now. No, it's not the answer. They all have a 1/2. 2 of the 3 have each lowercase letter. So like A is in 2 of them, B is in 2 of them, C is in 2 of them. So I'm actually going to divide everything by 1/2 ABC. We're getting the law of sines. So if I divide all of those by 1/2 ABC, that's just division property. I can divide an equal equation by the same value. So when I do that, the first one becomes sine of C over C. The second one becomes sine of A over little a. The third one becomes sine of B over little b. Now this suddenly is not a rule that we're going to use to find area. This actually looks like proportions. It's a fraction is equal to a fraction is equal to a fraction. And if we went back to that chapter we did on similarity, we solved problems like this, maybe got like a scale factor, or we did cross product to solve. That's what law of sines is going to be. It's a proportion. It's saying the sine of an angle over its opposite side is equal to the sine of another angle over its opposite side. So we're going to use that ratio. We get to it from that area formula, which we got to from the area of a triangle, 1/2 base times height, which we've known for years, hopefully. So, here's our law of sines. It says in any triangle, the ratio of the sine of each angle to its opposite side is constant. It's just a ratio we can use. We get sine of A over little a, sine of B over little b, sine of C over little c. All we can look at law of sines as nice proportions. We'll get some values. We'll have a missing one. Cross product, we get an answer. The only difference from when we did proportions in the past is we have sign involved. So we got to use a calculator. We get the decimal and we solve with it. But it doesn't always work. There's certain limitations. Now, there's what they call an ambiguous case. And it kind of relates back to when we talked about congruent triangles. You are not going to get any that don't work. Okay, we're not going to go that deep into law of sines where you have to worry about the multiple cases and multiple options. So the ones I'm going to give you for now will work. They always do. But it's important that we recognize sometimes what does and what doesn't work. Now, if you think of like angle, side, angle, that type of setup will always work. And what I mean is look at the first one. I have 2 angles, side between it. Whatever else they ask for, we'll be able to find, we'll be good. But that given information is angle, side, angle. It'll work every time, perfect. We could also go angle, angle, side. Bottom left is an angle, angle, side. It works, it's good, perfect. Now, angle, side, side. Didn't work back in congruence. it had multiple cases, and that's why it didn't guarantee exactly the same. Good, thanks for looking at the screen. Okay? It only works sometimes. Now, it's angle, side, side, sometimes. Maybe describes my personality. Anyways, the cases that it does work, and again, the cases that it does work, I'm not going to write them out. You're not going to have to worry about identifying when they come up. I've picked the problems that don't give the issues. But the ones that do work, it can be angle, side, side when the angle's obtuse. It works perfectly fine. It can be angle, side, side when the angle is acute and the opposite side is bigger than the adjacent side, which is more details that we need to worry about. We're just going to say sometimes, but I'm not going to give you any that give you multiple options. What happened back when we looked at this incongruence is it sometimes gave us multiple triangles. That's what happens. When it doesn't fit these certain criteria, it gives you multiple triangles, it throws it off, it doesn't work. Okay, so these work, we'll be fine. Now let's actually use it. So I got a triangle there. Law of sine says angle, opposite side. I want to look for the ratio. So right there, I got 80 and x. So I'm going to go sine of 80 over x. That's one of my ratios. My other ratio could be 35 over that side. But the problem with that is we don't know that side, and we don't care what that side is. So that's not used. The other one I can have is that 10 and angle A. So that's the other ratio, but I don't know what that angle is.
Oh, 80 plus 35.
Perfect. What's that going to be? Well, 80 from 180 is 100. 35 from 100 is 65. So that's sine of 65. Okay? Right there is the new part of law of sines. That's the difficult part, if you want to call it. It's just get the setup. Set it up, get your rule in place. Now it's cross product. It's not a nice cross product with whole numbers. It does use sine. It does need the calculator. But I'm going to go 10 times sine 80 equals x times sine 65. Okay, now I'll move over to sine 65, and it's 10 times sine 80 over sine 65 equals x. Careful on the calculator. Let's make sure we're practicing to make sure things go in the calculator correctly. Calculator does not understand your order of operations. It understands correct order of operations.
Oh, wow.
Oh.
Rude.
Okay, so did we get about 10.9?
Yes. I didn't screw up this time, guys.
Okay, now, let's just kind of a quick check. 10.9 would be opposite the 80. Does that make sense? That is opposite 80, while 10 is opposite 65?
Yeah.
Bigger angle is opposite the bigger side?
Yeah.
Okay? It doesn't guarantee you rounded correctly. It doesn't guarantee it's an incorrect answer. But it's a good thing to check just to make sure you got things in the right place. If I went back and looked at that problem and I got 10.9 and it's opposite to 35 degrees, that's an issue we need to go back and check. Okay? So I want you to try to set up and solve the next two.